In this video, we're going to look at solving quadratic equations by using the technique of factoring. And the process in doing this, how do I know I'm going to use this technique? It's going to be if you see the variable that is squared and also the same variable raised to the 1 power. And I could also see a question that is kind of like the very first one here, where I see the product of two binomials and I'm trying to solve. And it's a quadratic because p times p makes p to the second power. And so when I'm solving a question like right here, the first one, because of the product of p minus 6 being multiplied to p minus 4, they have to multiply together to be 0. What that tells me is that either one of those expressions, when I'm solving for a letter for p, if I make either one of them equal 0, then the entire equation becomes 0, because 0 times another number makes 0. So one option to solve here would be p minus 4 produces a value of 0, and I'd add the 4 to the other side, and I get p equals 4. So if I put in 4 for p, I get 0. And I have a similar scenario here for the p minus 6. If I pick a number to put in there that would make the p minus 6 factor become 0, to make my entire problem become 0 as well. So I'm going to say p minus 6 equals 0, solve for p, so I'd add the 6 to the other side, and that gives us p equals 6. So we have two possible solutions here. Now, let's look at the same thing graphically. And so I would type in, I'm going to use Desmos here, it's more user-friendly than our calculators. And so I have y equals the left-hand side, and then I have y equals 0, which is basically just the x-axis. And I'm looking here and I'm solving. And so look over here on the right-hand part of the screen, and we see that the intersection between the x-axis, which is represented here by this green line, and the parabola, which is the blue, happens in two locations. It happens at 4, and it happens at 6. All right, so graphically we solve when we get the same answer. All right, let's look at another problem here. Let's look at number 3. All right, so it looks a little different. I see v squared minus v minus 30 equals 0, and I need to solve that one. Well, number 1 was already in factored form for me to solve this. And so if I see problems similar to number 3, my goal is to try to get it in factored form so that way I can work to solve. Now, in order to factor and solve, I got to make sure the right-hand side is equal to 0, which it already is. And so I go through my process and I look at this, say, all right, well, I want to try to make two parentheses here. And the product of those two binomials is going to equal 0. And because the leading term has a coefficient of 1, I know that the beginning parts of these binomials are going to both be v's, because v times v makes v to the second power. And now I try to figure out, well, what two numbers will multiply together to be negative 30 that will add together to make negative 1? Well, those two numbers would be negative 6 and positive 5. All right, so now we have a problem that's set up just like the very first one we did. All right, and because we have the product of two binomials is going to produce a value of 0, if I zero out the factor v minus 6, then I would zero out the entire problem. So I'd solve for v, so I'd add the 6 to the other side, and I get one possible value for v to be positive 6. So if I put in positive 6 for v, it'll make the whole problem equal 0. And I do the same thing again for the v plus 5. So if I zero out the factor of v plus 5, then that was going to make me multiply by 0, and therefore zero out the entire problem. So I'd subtract 5 to the other side. So if v was equal to negative 5, it would also make the entire problem equal 0. And so let's look at this on Desmos here. So we'll graph number 3. So y equals the left-hand side, and y equals the right, which in this case is y equals 0. So I'm looking for the zeros of this quadratic expression, which is a fancy way of saying where does it cross the x-axis. And so I graph, I'm going to have to change my zoom here. and I see the parabola in red, and I have the line y equals 0, which is the x-axis, and when we're solving a system graphically, we're looking for the intersection point. So I have one at negative 5, 0, and one at 6, 0, and those are the same values that we have as well. All right, let's go on here to number 5. All right, so number 5 here, I see I have my variable squared, my variable to the 1 power, but this time it's not set equal to 0, it's set equal to 48. And so in order to solve this by factoring, I need to get one side of the equation equal to 0. So I have to move the 48 to the left-hand side here. I need to get everything on the same side. So I do that, and I rewrite my problem, and it becomes n squared minus 2n minus 48 is equal to 0. Now, we want to try to factor this. So that way we can solve. And so because the leading term has a coefficient of 1 again, I know that I'm going to have n times n at the front of these binomials. And now I'm looking for, well, what times what makes negative 48 that adds together to make negative 2? Well, 8 times 6 is 48. I need them to add together to be negative 2. So that means the 8 has to be negative and the 6 has to be positive. So I have this thing factored. And now we work back through our process to solve. So I can make the entire left-hand side equal 0 because we're multiplying two things together. If I can make the n minus 8 or the n plus 6 produce a value of 0. So I'm going to say n minus 8 equals 0, and I'm going to solve for n. I add the 8 over, and so I get n equaling 8. So one possible answer to this problem would be if n was 8. And another possible answer would be if I zeroed out the n plus 6 factor, and so I subtract the 6 to the other side, and that's going to give me n equaling negative 6 as my possible answer. All right, so we'll go back here and we'll look at this thing on Desmos as well. All right, so if we were solving the system by graphing, we're just trying to check our answers, and I graph my original problem. Y equals x squared minus 2x, and y equals 48 are the ones that I'm graphing. And so look over here on the top left, right-hand part of the screen. And my answers here should be the intersection of the two lines, or the curve, the parabola in this case, and the horizontal line. So I have one intersection with an x value of negative 6, which we got, and another intersection with an x value of 8, which we solved for as well. All right, number 7 here. All right, so number 7, I see x to the second power, x to the 1 power, and in fact, it's already set equal to 0 here. So we would want to jump right into trying to factor this. Now, this time, the leading term has a coefficient of 5. Now, we're fortunate because 5 is a prime number, so I know that I'm going to have a 5x, and I'm going to have an x here. And I also know that because I have two plus signs here in the middle, that it's going to be a plus and a plus. And so now we're looking and saying, all right, well, I need two numbers that multiply together to be 7, and I need to multiply one of the numbers by 5 and the other number by 1 to make it added together and be 36. Well, the only way I can do that is if I have 5 times 7, which makes 35, and then add to that one more, so 1 times 1 would give me that 35 and 1 adding up to be 36. And so there are my two factors. Now I want to solve these two. So I work through here and say, all right, I can make the left-hand side equal 0 via multiplication if I made the 5x plus 1 produce a value of 0. So I say 5x plus 1 equals 0. And then I work my way to solve. So I'd have to subtract the 1, and I get 5x is equal to negative 1. And then we would divide by 5. And so we get x is equal to -1/5 as an answer here. And then we also need to solve for the 0 of the second factor in this product, which would be if I made the x plus 7 equal 0. And so I'd subtract the 7 to the other side, and that would give me x equaling -7. And so the two values of x that would make my original problem equal 0 are -7 and -1/5. So let's check this here with Desmos. So I say y equals the left-hand side, 5x squared plus 36x plus 7, and y equals 0, and we're going to graph it. And so I look here at the top right part of my screen. I'm trying to find the points of intersection between the two curves. And so I'm touching here, I get x equals -7. That's good. I got to be very careful to make sure I actually get the intersection point and not where the line touches the intersection of the y-axis. And that gives me -0.2, which -0.2 as a fraction is -1/5. So we did that one correctly. All right, now I want to do one more. Let's go down and let's do number 9 here. All right, so I have 2x squared minus x equals 21, and I want to solve this one via factoring. So first step is to get everything on the same side. So I'd have to move the 21 to be on the left-hand side. So I'd subtract the 21 to the other side. That'd make it go away over here. And so I'd have 2x squared minus x minus 21 is equal to 0. Now we would set up our factoring technique. And I look and say, all right, well, x squared has a coefficient of 2. 2 is a prime number, so that means I would have the only things that multiply together to make 2x squared would be a 1x and a 2x. And now we look and try to figure out what times what makes -21. And if I multiply one of those numbers by 1 and one of those numbers by 2, they would add together to make -1. Well, you go through your list, you got 1 and 21. Well, that's not going to work if I multiply one of those by a 2 and the other one by a 1. Or one of those numbers would be negative. We got 3 and 7. Let's see, if I multiply the 3 by 2, the 7 by 1, and I subtract those, that would make -1. So there's my pair. So I need the 2x to multiply to a positive 3, and I need the 1x to be multiplying to -7. So there's my factors. Now we solve. So I can zero out the left side if either of those two products produce a value of 0. So I'm going to set the factor x plus 3 equal to 0 and solve. So I'd subtract a 3 to the right-hand side and get x equals -3. And I would do the same process for the other factor. So 2x minus 7. If that factor produced a value of 0, then I would zero out the entire left side as well. So here I would add the 7. And then that would give me 2x is equal to 7. And then I would divide by 2, which gives me x equals 7 over 2. And we'll take the second to check that with Desmos. So I would do, in Desmos, I would type in y equals the left-hand side, so 2x squared minus x, and y equals the right-hand side of 21. And we would graph it and give ourselves a good zoom where we can look and see. And I'm looking for where the two curves cross each other. So one of them crosses with an x value of -3, and the other one crosses with an x value of 3.5, which is